Hi friends, thanks for joining me. Algebra 2, Lesson 1. We're talking Saxon, Red Book, 3rd edition. We are talking Lesson 1, Polygons, Triangles, Transversals, Proportional Segments. It's a doozy, let me just tell you. So we're going to just jump right in here. Grab your notebook. You're going to want to write a lot of things down on this one. All right, first things first. We are going to talk about part 1, Polygons. Here's all the names. If you got 3 sides, it's a triangle. You got 4 sides, it's a quadrilateral. 5 sides, pentagon, so on and so forth. I'm not going to read this to you. Polygons are closed and they have no caves in them. You can have a concave polygon. I don't know why I wrote that in there. Let's ignore that. Disregard that information. Look at that. Whiteout is magnificent. Bam. Equilateral means all sides are the same. Equal angular means all angles are the same. Regular just means that all the sides and the angles are the same. So if you have a regular hexagon, that means you have all 6 sides are the same length and the angles are the same as well. All right, part 2, we talk about classifying triangles. We can classify it by its side by saying it's equilateral, isosceles, or scalene. If it's equilateral, 3 sides are the same. Isosceles, 2 sides. Scalene, no sides. Classify by the angles, you can say if it is, oh, look at that. I kind of smudged that. If it's acute, all the angles are less than 90 degrees. If it's right, you have at least one right, or you have only one right angle. If it's obtuse, you have one angle that is greater than 90 degrees. Angles always add up to 180 degrees in a triangle. I got to be specific there. In a triangle. Okay, so let's talk a little bit more about some triangles. We got this guy, isosceles triangles. Here's a good rule. If 2 sides of a triangle have equal lengths, the angles opposite those sides are also congruent. So let's think about that. Let me draw out an isosceles triangle here. So if I tell you, hey, these 2 sides are the same, this side is the same as this side, then that means that the angles opposite those sides are also congruent. Conversely, the converse of an isosceles triangle is that if you have 2 angles that are the same, then the sides opposite those are also the same. Equilateral triangles, if all 3 sides of a triangle are congruent, then their angles must be congruent and equal 60 degrees each. That's basically the rundown of that guy. In converse of an equilateral triangle is if 3 angles of a triangle are equal or congruent, that's the fancy way of saying congruent, and equal 60 degrees, then the sides are also congruent. Okay, so with that information, let's figure this out. So looking at this guy right here, example 1, I kind of wrote small, so we're gonna fix that. Example 1. So we know that in an isosceles triangle, these guys are going to be the same, which means then that x equals 50 degrees. X equals 50 degrees. I don't know that you can see that if I write it in pencil, so we're going to switch to pen. Because we have these 2 sides are the same, then the sides opposite them are also the same. So x equals 50 degrees. Now, if x is 50 degrees, what is y? Well, remember, it's 180 minus 50 degrees minus 50 degrees would give us 80 degrees. So y would equal 80 degrees because then we would have 50, 50, 80, and it would be 180, and triangles always equal 180. So this one is called the external angle triangle theorem. I can't remember what it's called, but here's what it says. It basically says that the outside of this triangle, the outside angle of this triangle is the same as the sum of the 2 opposite angles. So that means that y plus 40 is going to equal 150 degrees. So that means that if I minus 40 on both sides, I'd get y equals 110 degrees. So this is 110 degrees. So now that we know this is 110, we know that this is 40, that's 150. X equals 180 minus 110 minus 40 degrees. So that would be x equals 30 degrees. Okay, so always in our triangle, it equals 180 degrees. Just keep that in mind. All right, let's try some others here. We have, next one. All right, for example number 3 here, we have, let me slide that back down. This is an equilateral triangle, so that means that every angle inside here is congruent and they are all 60 degrees. If this is 60 degrees and this is 60 degrees, then that means D must equal 120 degrees because it's the exterior sum angle theorem. I don't know. I'll put it down in the comments. I'll look it up, the official word, right? All right, let's talk about transversals. Transversals are a line. So if you have two lines that are cut by a third line, then that's a transversal. Now, generally when we're talking about these, we're talking about two parallel lines that are cut by a transversal, but sometimes you can have a situation like this where they are cut. These are not parallel. A and B are not parallel. By the way, first rule of geometry is do not assume anything. Do not assume anything. No. Unless you are told that these are parallel, they are not parallel. And how are we told? If you look here, you'll see that we have these double arrows. There we are told, hey, these guys are parallel. So this is a transversal cutting two parallel lines. Okay, so over here, we look at this and we see that so on this one, we don't know that they're parallel because we aren't proving that. Now, corresponding angles. So we have two parallel lines here. Corresponding angles are things like this. This angle right here would correspond with this angle right here. If I were to like pick it up and put it back down, that's a corresponding angle. And it lands on the same spot. So like this one here would correspond with this guy here. Corresponding angles are always congruent. That is a good thing to remember. Okay, so also on this one, I forgot to mark, this is just an example that's in the book. I forgot to mark that these are parallel. And so if we have two parallel lines and the transversal is a right angle to one of them, it has to be a right angle to the other. So just keeping that in mind. Let me fix my camera here for you. Okay, so keeping that in mind. All right, let's see if I missed anything on that. I don't think I did. All right, let's do some practice. Lesson number 1 still, we've got a transversal here. So when you're looking at these guys, let me back up here. When we're looking at dealing with transversals, and angle relationships are what they're called. What you're looking for is, are they corresponding angles? That's the first thing you want to see. Remember, those corresponding angles are, like if I pick this up and I put this down right here, where would it land on it, right? It would land on the same thing. If they're not corresponding angles, then you're wanting to see if they are alternate or same side, aka consecutive, of the transversal, or if they're interior or exterior. So what do I mean by that? Here's our transversal here, and here's our two parallel lines. Are the points that we're dealing with, or you're asking about, are they alternate or consecutive? So if I have 2 points that are like one is right here and one is right here, those would be considered alternate because they're on the outside, or I'm sorry, don't worry about the outside. They're on the alternate side of the transversal. Whereas if I had ones that were like this, those green ones would be on consecutive, aka the same side. Okay, so you're looking, hey, are they alternate or same side? Then the next thing you're doing is looking, are they interior or exterior? So interior is going to be all along. Let me draw because I like to color. So this is interior, just means inside, right? And then our exterior angles are going to be on the outside here, exterior and exterior, including this way. Okay, so let's put this all together. So looking at this list of angles here, and my apologies if you are on your phone or something and this is kind of small. Sorry about that. Alternate interior angles. So alternate interior angles would be if we had on the inside here, so 3, 4, 5, and 6. Alternate would be 3 and 6 and 5 and 4. So angles, let me do it in a pen so you can see it. Angles 3 and angle 6, and then angle pair, angle 4 and angle 5 would be alternate interior angles. Now alternate exterior angles would be the ones on the outside, 1, 2, 7, 8. So alternate would be 1 is alternate to 8 and 2 is alternate to 7. So angle 1 and angle 7, angle 1 and angle 8, angle 2 and angle 7. Now consecutive, aka the same side, interior. So that would be, inside would be 4 and 6. So angles 4 and 6, or 3 and 5. Angle 3 and angle 5. Consecutive exterior would be the same thing. It would be on the outside, so 2 and 8 and 1 and 7. So angle 1 and angle 7, angle 2 and angle 8. Now here's the deal. Alternate interior angles, alternate exterior angles. These guys are, I'm going to find a pen that I can get it. We got to be very authoritative on this, so we're going to use another form of purple. I don't know. I think purple's authoritative. These guys are alternate interior and exterior. These guys are congruent. Consecutive, when they're on the same side, those are supplementary. And if you don't remember, supplementary are when you have two angles that add up to 180 degrees. So if they are on the same side, they're supplementary. If they are alternate sides, they're congruent. The only difference on that is corresponding angles are going to be on the same side, but one's going to be interior, one's going to be exterior. That's how you know it's not just like a consecutive interior, exterior. Okay, so let's talk about proportional segments now. Yay! Proportional segments look like this. We've got a bunch of parallel lines here. Whoa! Get right in there. We back up. So we have a bunch of parallel lines here cut by two different transversals. Because we are told that these are parallel, that means that these are going to be proportional, meaning 2 is to 3 as 3 is to 9/2. So 2 over 3 equals 3 over 9/2. Now we can test this theory because we can do cross products. What I mean by cross products are 3 times 3 would give us 9, and 9/2 times 2 would also give us 9. Therefore, they are proportional. So knowing that information now, let's go ahead and do this as a practice problem. So here we're trying to solve for x. So we have 2 over 5 equals, and since I did this on top, I've got to do this on top over here, 8/3 over x. Let's go ahead and cross multiply with that. I love fraction equals fraction because you can cross multiply. So 2x equals 5 times, and this is all about making sounds, I'm so sorry, 8/3 over 1. This was my favorite purple pen, but it's not working so great. I went ahead and put 5 over 1 just because I'm dealing with fractions, right? Cross multiply. So we have 2x equals 40 over 3. Come over here. 2x equals 40 over 3. Now, if I divide both sides by 2, I'm going to get a complex fraction. I don't want that, so I'm going to multiply by the reciprocal instead. So multiply by 1/2, and then these cancel out, and times this by 1/2. Now I can cross cancel. Divide this by 2, I get 1. Divide this by 2, I get 20. So x equals, upstairs I have 20 times 1. Downstairs I have 3 times 1. 20 over 3. That is about right. 20 over 3 here. Excellent. And you can kind of look at that because 2 times 4 would give me 8, so 8 over 3. 5 times 4 would give me 20 over 3. I'm just talking about the top part. All right, hope that makes sense. All right, let's do some practice on this, folks. Here are your practice problems. Let me cover up those answers straight away. All right, here are your practice problems, kids. It would help if you could actually see the practice problems. So sorry. Here are your practice problems. We've got the measure of angle A is 35. Find the measure of angle C and B. You've got these guys. So pause the video, do the practice problems, come on back, and then we'll do them together. All right, those are the answers. If you did not get that, stick around and we will do these together. So first things first, we know the measure of angle A is 35 degrees. So because this is an isosceles triangle, I'll zoom back in. Because this is an isosceles triangle, then we also know angle C is 35 degrees. If these are both 35 degrees, all I have to do is 35 plus 35 is 70. So I'm going to take 180 minus 35 plus 35, which is 70. 180 minus 70, that gives me 110. So angle B is 110. Angle B 110, C 35. Beautiful. Okay, now remember this outside angle here is the same as the sum of these two. So 40 plus y equals 145 minus 40 from both sides. We get y equals 105. So this guy is 105. Now, 105, 145, we take 180 minus 145. You can also do it because this makes a half circle, and a half circle or a straight angle is 180 degrees. So what would that be? That would give us 35 degrees right here. Bam, let's do this. All right, this one here. So we now know that, okay, here we have, this is 130 degrees, right? So corresponding angles, if I were to pick this purple dot up and I placed it on this purple dot here, you would see that 130 corresponds with B. So with 2B, I'm sorry, 2B equals 130. Divide both of these by 2. We get 65. B equals 65 degrees. Okay, so now that means that this is still just 130 degrees over here, but we know that B equals 65. Now, if this is 130, remember that straight angle, this has to be, A has to equal 50 degrees because a straight angle or a half circle here is 180 degrees. 130 plus 50 gives you 180. And if A is 50, so is C. Okay, let's do some proportions here. We have 3 over 4 over 6 over 5 equals 5 over 3 over x. So cross multiply, 3/4 x. Let me slide this over here. Equals 5/3 times 6 over 5. All right, let's cancel out these 5s. So I just multiplied those times. Divide by 3, I get 1. Divide by 3, I get 2. So I have 3/4 x equals 2. If I'm multiplying here, opposite of multiply is divide, but we never divide fractions. We multiply by the reciprocal instead. Put that over 1, multiply that by 4 over 3. Cancel, cancel. X equals 8 over 3. So my answer is 8 over 3. Hopefully that helps. I look forward to seeing you this year or however long you're doing Algebra 2, and we'll see you next time.